talk is TypeScript versus KotlinJS, and we love both Kotlin and TypeScript. So this is a bit like choosing which child you love the most. So who am I? My name's Eamonn Boyle. I work for a company called Gearset. I'm the development manager of our Belfast office. And Gearset are a DevOps solution provider for Salesforce platform. And this is a role I've just moved into for a few months. Prior to that, I worked with Garth.
Yes, so my name's Garth Gilmour. I work for a company called Instil in Belfast, where Eamonn used to work and has now left us. Damn it! Sorry, it's okay. It's okay. It's fine. Instil are a software development and consultancy company. So we build systems. We have full-time developers working on projects, but we also have a consultancy and training department, and that's the part that I run.
Cool. Thanks, Garth. So, as I said, we really love TypeScript, and TypeScript to me is good engineering. In our industry, there's way too much waste. We're constantly reinventing the wheel, not always necessarily solving a problem, just trying to do it a different way, or going for something new and shiny, or adding a very minimal amount of additional functionality. TypeScript solves the problem of lack of types in JavaScript, which is a real problem. Dynamic languages generally have worse tooling, worse static analysis, and for me, and Garth, we're always going to want to use statically typed languages. And TypeScript brings statically typed languages to the JavaScript ecosystem. But it does it by adding a small amount on top of JavaScript. It doesn't throw away the effort of the 13 million JavaScript developers that are out there. It doesn't throw away the effort of 2 million NPM packages that are there. They say, OK, let's realize that this world exists, and let's build on top of it. So for me, it's really good engineering. It brings me the static typing that I love, and the Interop solution for JavaScript is just superb. Kotlin is very, very similar. So for me, coming from historically C++ and then C#, and really, really liking C# and .NET as a platform and as a language, coming to the Java virtual machine, I sort of saw Java as a bit of a problem. I didn't really like the language, and Kotlin for me solves that problem. Kotlin has all the features that you want in a modern language. It allows you to write clear, safe, succinct code. But again, it didn't say, OK, let's just reinvent the wheel and start from scratch. The Interop solution with Java is really good. We can leverage all the Java libraries. There's really good wrappers around the key things that you want. So for me, again, Kotlin is like super, super good engineering. So both of these we really like. Both of these are what we choose when they sort of make sense in the context of what we're building, and we see them as improvements on what's there. But Kotlin wants to be everywhere. Kotlin wants to own all the things. So now we can take Kotlin and we can target it for Android, we can target it for the JVM, which is where it started, and we can now do it native as a bit of a Swift replacement, and what we're talking about here, KotlinJS. So for me, KotlinJS is interesting because the language is so nice, but then I also have this really good solution, which is TypeScript. So we wanted to see how these things compare, and we've done this a few times now. We've looked at it, we've done a couple of projects in this. We're not, in all openness, we're not using this on real projects that like earn us money. Everything's been through workshops, labs, and various different things, and towards the end, you'll maybe see why that is the case. But we're building projects, we're using the standard things that you want to do when you're working in this space. We're using things like React and Redux, doing REST, building forms, all these kinds of things, and then looking at what the tooling experience was like, what the language is like, what the interop is like, and just trying to figure out, OK, is this worth doing? So we had to start by creating some KotlinJS projects. Garth.
Very good, thank you. So if you go into IntelliJ, it'll give you a really nice wizard for getting started with KotlinJS, which is built on top of Gradle. So you can stick with the build system that you know and love if you're coming from Kotlin on the JVM. And yet, as we'll see in a second, it's still very easy to integrate in NPM packages. So this is the wizard that you'll be confronted with. It's changed a little bit recently, so this might be new to you even if you've done it before. On the left-hand side, you want to go for Kotlin multi-platform, and then you get various choices on the right-hand side. So you see there, underneath KotlinJS, we could go for KotlinJS running in the browser with no extra libraries. So you would just be using the low-level document object and DOM API, that kind of thing. Or we could do this on the server through Node.js. But for all the code that we're going to show you in this presentation, we went for React application. So we're choosing to create a React-based user interface that will run with KotlinJS inside the browser. And for the DSL, you can go for the Groovy-based version of Gradle or the Kotlin one. Of course, we go for the Kotlin one. And then there's this little follow-on menu here that will allow you to specify extra bits of React or choose the more modern compiler. So at the moment, all of the Kotlin compilers are being harmonized together. So they all agree in a format called IR. But that's still a little bit new for us at the minute, so we didn't want to build the demo around that. It's just a little bit too new. So if we were doing Kotlin native, then it would build some kind of executable. If we were doing Kotlin Java, we'd build some kind of jar. Because we're doing KotlinJS, it's just going to build us a big bundle of JavaScript through the miracle of Webpack. And the good news is that they've broken up the documentation very well. So when it comes to the Kotlin libraries, certain libraries are only available in native, certain libraries are only available in Java because they're based on top of JVM libraries and so on. But as you can see in the documentation, they give you breadcrumbs. So you can immediately tell if a particular library will be available in KotlinJS. So that's good to see. And as I say, everything's based through Gradle, so it is a regular Gradle file that you get confronted with. You still have standard plugins like the plugin for serialization, but this time, as you can see there, it's the KotlinJS compiler that we're going to be using. And then down the bottom of the file, there's going to be a little bit of configuration for precisely how we want to use it. Again, they've harmonized and they've come up with a new universal backend for the compiler and so on, but we're just going to stick with the legacy compiler for now. And you get these targets here. So if you double-click, for example, on browser run or browser development run, then everything will get built, will get deployed. It'll pop up a browser window, and you'll be able to see your web app up and running. So that's all cool. And then looking at the dependencies section inside the build file, you can see the first set of dependencies there. These are pre-built wrappers around existing libraries. So you get given for free KotlinJS wrappers around the existing React functionality. For most other things, though, you'll have to bring them in directly, so you can do that using the npm function. So you see here, we're bringing in Bootstrap. So any existing JavaScript library, you can bring it in yourself like that. But again, for convenience, you might want to wrap it up with some helper classes. And this is how everything starts. Yeah. So good old main method, nothing scary about that. You can see down the bottom we're creating an app object. So our main type in these demos is going to be called app, and then we want the output of that application to render inside the browser. And the low-level details of how we do that, well, as with regular JavaScript, we've got the document object. So we can go ahead and we can create a good old div, and then we can just add that into the body. So you can see it's good standard DOM programming there. So nothing scary if you've ever done Hello World in JavaScript. And whenever it comes to writing React components, well, this is what we'll be showing you in a lot more detail as we go along, okay? But suffice to say, it is very easy to create a React component in KotlinJS. But we'll dig into this in a lot more detail as we go. Yeah.
Cheers, Garth. So as I've done more and more development, I've sort of come to the realization that one of the biggest factors in terms of getting success is the community that you're getting exposed to and working with. So you want to have really good documentation. You want to have all the answers on Stack Overflow. You want to have all the bugs ironed out by other teams and by other people. So you have to reach a critical mass in terms of adoption before it's going to be easy for you. So you can be an early adopter, but you're going to be fighting. And whenever your revenue depends on that, then that can make you a little bit reluctant. So we're going to look at community as round one in terms of our comparison. So Kotlin as a language has, continued to improve and go up various different programming rankings. Again, you've got to take these things with a pinch of salt. Like how do you sort of understand how popular it is? Is it by the number of questions in Stack Overflow? Is it the number of commits in GitHub? But by most measures, Kotlin sort of continues to go up and up and up. Saying that, in the JavaScript space, TypeScript is by far and away the most popular alternative to JavaScript. JavaScript, by most measures, is the most popular programming languages. So for several years and many of the different rankings, it's number one. And in that space, the alternative to JavaScript, TypeScript, just dwarfs everything else. So TypeScript has got this massive community. It's already established in this space, which means that KotlinJS, not Kotlin, but KotlinJS, has this uphill battle to overtake. So in this round, TypeScript has to win. It's just more popular as a language, it's more popular in this space, and as a superset of JavaScript, it means that a lot of the questions and documentation issues that you require are JavaScript documentations and JavaScript solutions. So whenever I'm programming TypeScript, a lot of times it's, how do I solve this in JavaScript? Because that answer is immediately readily consumable for me as a TypeScript programmer. So what about interop with JavaScript? So what happens when I want to reuse the JavaScript assets that are out there? As Garth said, in the project file, super easy, and you can mix and match with your normal Kotlin dependencies and your Kotlin multi-platform libraries. You can just put in your npm dependencies, so that's quite nice. There are a few wrappers. These are really nice. They're first class. There are some libraries out there as well, which are sort of written, which you can immediately consume. But most of the stuff out there in terms of the JavaScript space, you're going to have to wrap up yourself. So how do you do that? It's actually super easy. If you're familiar with TypeScript definition files, type definition files, it's very similar to that. You're importing the library, and then you create a file like this, which says, okay, in this library, there's these things defined, and this is the type definition if it was in Kotlin. So it's very, very easy to pull in any library and just stick in a wrapper. But if the library is large or you're bringing in many libraries, then even though it's easy, it's still a lot of work. And if the library is changing, then you're going to have to maintain that. So there is still some effort here, but generally speaking, it's a pretty good story. You would expect there to be some sort of automatic generation for this. There is, Ducat, but it hasn't been developed for a number of years. It's still said to be experimental, and it's on hold until the things stabilize in the compiler level. And this does help somewhat. You can take a TypeScript definition file and then generate a Kotlin definition file or Kotlin binding. And for simple cases, it works really, really well. The problem is whenever you start looking at more complicated flows, and we start seeing maybe some features of TypeScript that are maybe not readily supported in Kotlin, that the tool will give up or will make a guess that's not very good. So a lot of times you will have to come back in here and modify these files if you went through automatic generation. So you can use Ducat to sort of start you off here, use it from the command line, use it from the Gradle build instructions. There's actually integration with the standard build that'll always run it, but you're probably going to have to go in and patch this and sort of edit this manually. And it's just because the languages aren't compatible, but we'll get into that a little bit more when we start looking at it within React. Other stuff around interop with JavaScript, there's some good escape hatches, like you might expect. So you can use the dynamic keyword here, or the type here, to allow yourself to have any kind of object. So this'll allow you to basically drop down to JavaScript and have things that are untyped. You can also create JavaScript objects like literals like we do in JavaScript and TypeScript using JSO. Used to be JS object. They're still changing things, still evolving things. But this allows us to work in the same way as we would with JavaScript of just creating literals on the fly. But within the Kotlin space, it uses generics and everything's strongly statically typed. So you will get your autocomplete, your refactoring, all of that good stuff that we like from statically typed languages. And if you're really, really stuck, you can write JavaScript directly in there as strings, but this is really a last resort.
Yeah, so the goal is to avoid using any of that.
Yeah, as much as possible. Or if you do it, put it inside a wrapper, inside a library, so you never have to look at it again. So again, in this round, the interop story, again, it's not really a fair contest here because TypeScript is a superset of JavaScript. But in this round, TypeScript's going to have to win. JavaScript is actually valid TypeScript. You can take the TypeScript compiler, throw it at JavaScript, and depending on your compiler settings, it's just a really good static analysis engine. So it's not really a fair contest. But yeah, KotlinJS, the wrapping is pretty good. The project settings are pretty good, but TypeScript just pips it at the post.
Very good. So turning now to have a look at the generation of the HTML. So obviously, if you're going to be writing a UI in React, dynamically generating HTML is going to be your biggest job. So the way this would be done in a traditional component would just be like this. So here we're using TypeScript, but all we have at the end of the day is a Lambda, and inside that Lambda we have some embedded markup. So we're using a technology called JSX. So for those of you who haven't done React before, JSX just lets you embed markup directly inside your JavaScript code. And then in that markup, you can embed JavaScript code using braces, and in that you can embed tags, and in that you can embed braces. You get the idea. So it's very, very convenient. It's very, very minimalist. It's a really easy way to dynamically generate your HTML. So in the Kotlin version, you have a DSL. So there is a domain-specific language that provides the same functionality. And you have to pause at this point and give some kudos to Kotlin, because the ability to quickly create DSLs for any purpose that you can imagine, this is one of the major strengths of Kotlin. This makes it a good language.
And this is the second DSL that we've seen today because they also have the DSL in the build scripts for Gradle.
Yeah, so even the Gradle build script itself is a Kotlin DSL. On the other hand, whenever you compare this to the JSX, there's more going on, okay? The JSX is clearly simpler and shorter, yeah? So you see here there's a section called attrs, yeah? So that's where all the attributes that would be in the HTML get put in there. That's obviously a big namespace, so we say on-click function just to make sure that it's obvious that this is an event handler. You have to write builder functions to supplement your components down the bottom, as you can see. Or at least you did, yeah, because whenever we were preparing for this talk and the workshop that we did yesterday, I do what I always do, which is I recreate all the demos. So I go into IntelliJ and I run the wizard, and then I write everything again from scratch, copying and pasting when I get stuck. But I do try and generate everything from scratch. Yeah?
What's copying and pasting?
I don't know. It's just that came into no idea. Yeah.
Okay.
So it turns out that they've upgraded the DSL. There is a new version of the DSL which is better, but I had to go looking in the change log to make sure of this. And there's the wonderful instruction at the bottom saying, if you're migrating to this new API all at once, good luck, okay? So my response to that was the South Park response, okay? We're not allowed to swear in these presentations. But that was a little bit of a boom, yeah? However, it turns out the DSL, the new DSL, is much, much nicer. So the attrs section has been removed. On-click function, you can see there, it's just on-click again. The attributes are cleaner. The builder functions are not required. It is really, really nice. They just haven't got around to documenting it yet. So I raised this issue with JetBrains, and the documentation is on the way. It just needs to catch up with the new version of the technology. But when has that ever happened in our industry?
I mean, they wished you good luck. As engineers, that's all we want.
Yep.
Yep. A hearty good luck and working to 2 o'clock in the morning to update stuff. Yeah.
Yep. So what we learned the new DSL, and it is much nicer than the old one. They have made a ton of improvements. That being said, the JSX remains nicer.
Yeah. So, and again, this is sort of going back to the interop. So again, I'm sort of doubling down on the interop thing here. So again, I feel a little bit bad about this, but TypeScript has got a really powerful type system, and Part of that is the requirement because it's in a JavaScript space. And JavaScript space, as we all know, is mental. In JavaScript, you can do whatever the hell you want because it's a dynamic language. You can say, hey, today I'm going to use a different data type, and today I'm not going to put this field in this object, and whatever you want. So if TypeScript is going to bring static typing and enforce rules, those rules have to be pretty expressive. So even in like really, really simple things, like say in like an input that might have a min and a max, in the TypeScript definition, this can be a number or a string. So we can pass in a number or a string. The value is even more complex. It can be a number or a string or maybe an array of strings. So we have sort of these complex types inside TypeScript called type unions. We also have intersections, which are saying, let's take two arbitrary types and create a new type, which is the combination of both. And again, this is super useful in various different scenarios, especially when working with generics. So again, in the React space here, we can take in props that some provider gives us, and then we can say, but the type of this variable is not that props type, it's that props type and an optional children field. So we can do all this sort of type manipulation and do derived types in TypeScript. And this doesn't play well with a language that doesn't have these sort of core features. So if we go through the Ducat auto generation again, we get various different results when we start to use these. So here we've got a TypeScript definition, which is a union, and then we have a function which is taking that union as an input, and a function which is taking that union as an output. For the input, the story's not too bad, because we can have a function which can take either a first or a second by simply having two functions, having overloads. And true overloads is something that we don't really get in TypeScript or JavaScript, so this is actually a really nice feature for Kotlin. If the union is large or we have multiple unions, you can imagine the number of permutations that would have to be created there. But again, if it's all been auto-generated and you just get nice autocomplete, who cares really? Coming out of the function though, it's just marked as dynamic. So we lose a lot of our static typing on the way out, which is a big drop. When we get into intersections, the story is even worse. It's also bad. Here we have an intersection, and we have that both as an input and an output again. And basically what happens is we lose the second half of the intersection. So the type coming in and out is just first instead of first and second. So I'd have to do some sort of casting and as dynamic type stuff to get that to work. So on the automatic generation, you just don't have the same language features to support it. And TypeScript can go absolutely bonkers. We can do crazy things with map types. We can do conditional types. We can do recursive types. There's template literals for building up strings that are a certain shape, can we do some really nice things with that.
Eamonn, would there be some kind of workshop where people could learn about these advanced features if they so desired?
Yeah, I heard about this TypeScript lab tomorrow.
Yeah,
really
taught by two highly qualified and very friendly and professional instructors, I believe. I mean, that's the word.
One of them is, anyway.
Okay.
So, yeah, we will be talking about this stuff more tomorrow if you want to come along to the lab. So, I mean, I'm being a little hard on Kotlin because this is just really an incompatibility between these two languages. You can solve the same problems. You can do the same kind of work using Kotlin features. You just might have to, if you're working in a JavaScript space, you might have to create some additional wrappers. So here's as an example where useEffect in React has several different versions. You can have an optional second parameter. The first parameter that you pass in is a function that can have one of two different kinds of return type. And this is sort of fairly easily described in TypeScript. Inside Kotlin, though, you sort of have to jump through hoops. And there's been a couple of different variations in this depending on which version of the wrapper you're going with. So they had a useEffect and then a useEffect with cleanup. Totally different name. In some ways, it's clearer, but you have to do a little bit of extra work and use something that's different than the existing documentation. And then in the latest version, they've got several different forms here. We've got useEffect once, and then within the body, we have these helper methods to set up, clean up. So even within the team, they've got like two different solutions to the problem that they can't express what's been written in TypeScript. So it just means that the transition is not quite as smooth. You just have to do a little bit more work. So again, it's a little bit unfair, but I think the TypeScript JSX solution is just going to be a smoother path for you if you're building solutions for your company. The DSL is purpose-built. JSX is a DSL purpose-built for HTML, so it just feels natural to designers. You can consume assets more readily. it's just purpose built. But you have to give props to Kotlin for just having the ability to construct any DSL for anything, And again, we have a colleague who wrote a good article. What was his DSL on?
Oh, yes, quite right. Wasn't that for sandwiches or something?
Yeah, so he wrote a DSL for constructing sandwiches. So yeah, it's kudos to Kotlin, but again, if I'm building solutions, I'm going to want JSX TypeScript.
Yep, very good. So moving on, as I was saying previously, you're going to spend an awful lot of your time dynamically generating HTML. You're also going to spend an awful lot of time making asynchronous calls to back-end services. So let's have a little talk about that and how it works. So if you're doing TypeScript or JavaScript, you've got async await. So we can declare a function as being async because it's asynchronous, and then we can await the result of an asynchronous job of work. And that works really well. Yeah, that's good. But then in Kotlin, we have these things called suspending functions, which are even better. So a suspending function is a function that can suspend, yeah, and normally it suspends whenever another suspending function is called. But in the case of KotlinJS, it also works with promises, okay? So it'll also work here, you see, whenever we've made the call to await. So Kotlin has suspending functions, and suspending functions are kind of like a higher level tool, okay? They're a more powerful concept. And for example, we don't need to call await, yeah, because Kotlin is able to work out when one suspending function is calling another suspending function, and it'll add the wee icon in the gutter on the left-hand side to let you know what's going on. So there's no need to put in the calls to await. There's no worries about the bugs that might occur if you leave the await out and so on. So that's a really nice feature. So here it's the KTOR client that we're using, KTOR being JetBrains' RESTful framework, and provides a client as well. And as I say, suspending functions and also coroutines, these are a higher level concept. So async and await is designed entirely for the use case of awaiting asynchronous jobs of work. But suspending, you can use suspending functions anywhere that you want to use lazy evaluation. So here's a simple example. We've got this sequence generator, and what it's going to do is it's going to yield back a number and then do nothing until the calling code needs the next number, okay? So if you were trying to generate a list of infinite length, well, that would be done eagerly and it would never complete. On the other hand, there's nothing wrong with having a sequence of infinite length because it's only whenever a new value is required by the calling code that it actually gets yielded back, okay? So suspending functions and coroutines, they're a higher level concept. There's much more going on. There's a huge range of use cases that they can be applied to. And having walked up to that black hole of complexity, we're just going to step back from there, okay? But it's a fascinating area. And then moving on to talk about the syntax. I think this was me as well, wasn't it?
Yes, I believe so.
This is me as well. Very good.
You're very elegant, you see, so you get the elegant syntax.
Oh, I get the elegance. Thank you, yeah. Kotlin, if you ever want to annoy somebody on the Kotlin team, go up and ask them where's the ternary conditional operator, okay? That they really hate people asking that.
My recommendation as well is do that after a few glasses of wine.
Oh, yeah, absolutely, yeah. Because Kotlin doesn't need it, yeah. So in Kotlin, the when, which is used for pattern matching, and the if, these actually return things back to you, that they're expressions, okay? So the if statement actually returns a value, and that means that you've got no need for the ternary conditional operator. You've also got lots of other nice little things. So instead of the void type, which for example can't be used as a type parameter, you've got unit instead. If your function contains a single line, you can just say equals and so on. So for example, here's a little bit of TypeScript, and we're doing our JSX. Obviously, we've got that div tag there, but inside JSX, you can't use statements, okay? So inside JSX, you can't put an if, you can't put a switch, you can't put a loop. And this is a common problem for beginners because, of course, they want to do that. So they have to learn to use the ternary conditional operator instead of an if or a switch, and they have to learn to use the operators of functional programming, the filter, the map, and so on, instead of using loops. But you get there in the end. But here, we've chained some ternary operators together to get the effect that we want.
And I mean, this looks pretty good, actually, but this is sort of very hard work in terms of laying this out. As soon as you throw the auto formatter at this,
Yep.
it looks horrible.
Yes, work has gone into making this look okay. But again, as you say, any auto formatter will destroy your hard work. So if you look at the Kotlin equivalent, because in Kotlin, this is an expression and not a statement. So the when is actually going to return something. Yeah. So when combined with the DSL, that actually looks nicer. Okay. So I don't want to slag off TypeScript. I love TypeScript to death. But as Eamonn says, they made the choice to build on top of JavaScript. And that meant that any JavaScript developer could very quickly become a TypeScript developer. Yay. Yeah. But they also had to live with all the problems with the existing JavaScript syntax. Whereas in Kotlin, they were creating a new syntax from scratch. And as I say, when embedded in the DSL, that can become pretty nice. To look at it the other way, though, both Kotlin and TypeScript support destructuring, a feature coming to your language soon if it doesn't already have it. And the destructuring potential that you get in TypeScript is so much more powerful, okay? So if there's one thing I would add to Kotlin, it's extra support for destructuring. So what you can do is you can just go to an object and you can extract arbitrary properties on the fly, which is really nice. And it doesn't need to be some kind of data class. It doesn't have to be a collection. It doesn't have to have special methods implemented. That just happens automatically. You know, you can go to an object and rip out multiple things. And this is really useful whenever you're writing your components, because let's say we're passing in a big bag of properties, okay? So into this component called brick, we're passing a big bag of properties, but all we care about is the index, you know, so we can just destructure that out immediately. So really, really nice. And it works with collections. Yeah. Cool.
Cool. So what's the conclusion? They're both really good. But just in different ways. We love them both, but they have their pros and cons. You sort of heard us talking about where one was better than the other, and as we sort of write them all down, we are flip-flopping. And if I'm writing TypeScript, there's some features around the standard language and not having, having void instead of unit and not having a good switch expression and things like that. There's things that I really miss from Kotlin when I'm in TypeScript. And then when I'm in Kotlin, there's things that I really miss from TypeScript. And I'm like, oh, give me union types and intersections and let me do some of that sort of stuff. So they're both really good, but they have sort of different pros compared to the other. But what should you choose for your your next project with your company, the thing that's going to actually bring in revenue, the thing that you're going to have to maintain, the thing that your team are going to have to maintain? For me, I'm a big fan of like stable engineering. We Googled stable engineering, and this is what came up, so we stuck with it. I think it makes sense. So I'm going to want something with a larger community. I'm going to want something where the bugs have been ironed out. I'm going to want something with good documentation, not just a good luck in the changelog. So for me, yeah, the TypeScript is going to be where it's at. If I'm doing Android or back-end JVM development, Kotlin's a no-brainer. But for this, for building on top of the JavaScript ecosystem, KotlinJS doesn't solve enough problems. TypeScript solved a problem for me, and that's why I use it. I don't have I now have a solution, so I don't need to move to another language like ReasonML or KotlinJS at the minute. So that's where my brain's at. Garth?
Yeah, no, very much. I would agree with the same thing. At the end of the day, you're going to learn JavaScript. I mean, the argument that you'll get from an awful lot of people is, what happens if you have a team of rabid Kotlin developers really enjoying Kotlin on the server side, no experience of JavaScript or React? Wouldn't it be simpler for them to go with KotlinJS and React? Well, whenever they Google something, whenever they look it up in Stack Overflow, they're going to get a JavaScript answer, maybe a TypeScript answer if they're really lucky with the types added. So they're going to end up learning the material at the level of JavaScript and TypeScript anyway, so why not follow the line of least resistance for now? Might be different, of course, if you're not building a really big web app. As you know, there are software development teams in all kinds of companies. Not everybody is a software developer working in a software development company with a product that's being deployed to the world. So, for example, you might be doing Kotlin for all all kinds of crazy stuff. In a manufacturing company on the factory floor or whatever, you might need to generate HTML. That DSL might be incredibly useful, you know? So just because you don't want to grab and consume the whole thing and write your next big web app in KotlinJS doesn't mean there aren't pieces of this, you know, that you can't take away and use.
Yep. So, thanks very much.
Thank you.